Hi, we're going to be looking at a bit of an introduction to circular functions and looking at some angles in both degrees and radians. Now, we base a lot of this on the unit circle, which is a circle of 1 unit in diameter. So if we were to look at this particular thing I've got drawn here, it goes through to +1 and -1 on the x-axis, and it goes through to +1 and -1 on the y-axis. So we have a radius of 1 unit for this particular circle. Radius is 1 unit there. Now, you might not have seen this thing radians before. What a radian is if we were to get the radius of this circle and wrap it around the perimeter to about there somewhere, that then would give us a definition of 1 radian. Now, we quite often use a little c as a symbol denoting radian angles as opposed to degrees, which would have a little circle. Now, 1 radian is approximately equal to 57 degrees. I'll write that up here. 1 radian, it's approximately equal to 57 degrees. When we're measuring angles, when we are using one of these unit circles, is we have to start at the x-axis over here, and we need to travel around anti-clockwise. So that's the direction that we always measure the angles with this. So that's the positive direction of angles when we're dealing here. Now, if we were to take this radius, we've seen that it wraps around once to about there, that's 1 radian. And if we were to put another one on there, it goes to about there. Third one would go to about there. So 3 radians, so it's 3 and a bit radians, goes into 180 degrees, or more accurately, pi radians, which is 3.141592, whatever you've memorised it to. So pi radians is equal to 180 degrees. And we can keep going all the way around the circle, and we get to 2 pi radians is equal to 360 degrees. So that's where we can have a conversion factor, where we have pi radians is equal to 180 degrees, or 2 pi radians is equal to 360 degrees. And that's always going to be the conversion that we use, and I'll show you how to use that in some calculations shortly. Now, what I'm going to do here is show you a few equivalent fractions. So, starting over here, we have 0 degrees, and that's going to be the same as 0 radians. We've already worked out over here on the other side is we have 180 degrees. It's not 186 degrees, it's 180 degrees. Draw that one again. Is equal to pi radians. And if we go all the way around, there's a little c that denotes radian measure, but quite often that can be ignored. And if we keep going all the way around to 360 degrees, okay. Now, halfway point, going around in the positive direction. So we're always going anti-clockwise, which is a positive direction. The halfway point to 180 degrees is 90 degrees. Okay, and that's equal to 1/2 of pi. So when we're dealing with the fractions of the top half of the circle there, we just look at pi, and what's the fraction of pi? So this is equal to 1/2 of pi, or it's just equal to pi over 2 as our equivalent. So 90 degrees is equal to pi over 2. We can do the same thing going from 180 around to 360. Now, we need to count, as I said before, from 0, so this is where we count from. So this section here is a half of pi. This is another half of pi, so a whole of pi, or 2 pi over 2. And then coming around to here is the third half of pi. So this would give you 3 over 2 pi, or 3 pi over 2, which is equal to halfway between 180 and 360 is 270 degrees. Okay. Now, let's look at some more fractions. The halfway point between 0 and 90, which is 45 degrees, that area there, that's 45 degrees. I've just written into that one. Okay. 45 degrees, how many times does 45 go into 180? It goes in 4 times. So we can actually specify this 45 degrees as a quarter of pi, and that's because, a quarter of pi, that's because that 45 goes into 180 4 times. So a quarter of pi is the same as pi over 4. I might just get rid of that little arrow that's there. Can I get rid of that? No, I can't. Oh well. So 45 degrees, the next 45 degrees brings us around to pi over 290 degrees. If we had equivalent fractions, this would be, I'm just getting a different colour here, a quarter of pi, so we've got 1 quarter there, then a second quarter here, so that would then mean that pi over 2 is equal to, we've got 2 of the quarter pi, so that's 2 lots of pi over 4. And we're just looking at equivalent fractions here. So this is a half, and this is 2 over 4, which is also equal to a half. So that's where we get a bit of the maths coming in as well. Now we go around the third one of these, around to here. So this is going to be 3/4 of pi. So we've got a quarter plus a second quarter plus a third quarter is 3/4 of pi, or 3 pi over 4. And that's equal to, so we've got 45 plus another 45 is 90, plus another 45 is 135 degrees. And then we go all the way around to this 180 degrees, which is the same as 4 pi and 4, because you've got 4 quarters that made that up. Okay, and those 4's just cancel down to give you pi. And the same sort of thing can happen as we go around down to here, which that's 5 pi over 4, or 5/4 of pi. And then we've got 6/4 of pi, which is the same as 3 over 2, and it goes all the way around here to 7/4 of pi, or 7 pi over 4. And we can write the equivalent degrees for each one of these. So 180 plus 45 is 225 degrees. And then we go around to 270, and then 270 plus 45 will be 315 degrees. And we can do the same thing with other angles as well. So another common angle we have is 30 degrees. So that's 30 degrees there. How many times does 30 go into 180? 6 times. So that will be equal to 1/6 of pi, which is just pi over 6. We can get the second lot of 30 degrees, which is 30 plus 30 is 60 degrees. And that will be equal to 2 lots of pi on 6, which is equal to pi over 3. I'll write that over here. So 2 pi on 6 equals pi over 3. And then we come around to here. This is 3 pi on 6. So again, 3 over 6 is a half, so half of pi. And then we come around into the next part here. We get to 4 pi over 6. So every time we add an extra one of these little green lines or green segments is 1/6 of 180 degrees, or 1/6 of pi. So 4 pi and 6, that's equal to 90 plus 30 is 120 degrees. We come around here, the next one I've already drawn that's 5 pi over 6, which is equal to 150 degrees. And then we come around, we've got 6 pi over 6, which is equal to 180 degrees. And again, the 6 over 6 cancels down to make 1. And we can keep going around down below here. So we've got 7 pi over 6. That's equal to 180 plus 30. 180 plus 30, not equal to 30. 180 plus 30 is 210 degrees. Come around down to here. That's 8 pi over 6 is equal to 210 plus 30 is 240 degrees. And then we come around to 9 pi over 6. I'm just going through all this systematically just to show you that we get the circle, we can break it up into all these different segments. So that's 9 pi and 6, then we come around to 10 pi and 6, which is equal to 270 plus 30 is 300 degrees. And then we have 11 pi on 6. And then in here we have 12 pi on 6. 12 divided by 6 is 2, and we get 2 pi. And then if I get a different colour again, I'll go into red here. The other thing that divides it nicely into 180 is 60. So I've already got a lot of these 60 ones. So we have one line in there. 60 degrees is equal to 2 pi on 6, which is pi over 3. I think I wrote pi over 6 before. The second one of these is 120 degrees. So at 120 degrees, that's 4 pi over 6. If I cancel the 4 and the 6 down, it gives us 2 pi over 3. Then the next one over here, 3 pi over 3. Then we hit the next one over here, 8 over 6 is equal to 4 pi over 3. Then the next one will be over here, 10 pi over 6 is equal to 5 pi over 3. And then we come back around to 2 pi, which is equal to 6 pi over 3. So we can have a half a circle, which is 180 degrees, and we can divide that up into any number of fractions. The nice comfortable ones are 30 degrees, 45 degrees, 60 degrees. So we've got a bit of a mess there, but that's the different ones that are there. I'm just going to go through now how you do some conversions between degrees and radians. First one we have here is convert 30 degrees to radians. Now, if you remember, the relationship that we had was that pi radians was equal to 180 degrees. So if we're going to convert from degrees to radians, then what we need to do is we multiply by radians on top, pi, over degrees on the bottom. We want to cancel down the degrees. I'll write the 3 for. The whole thing again. So when we're converting to radians, we multiply by pi over 180. So in this instance here, what we need to do is we go 30, multiply by pi, divide by 180, cancel down where we can. 30 will go into 180 6 times. So that will give us an answer of pi over 6. Now the next one that we have here, maths won't be quite as easy, but it's the same process. We have to multiply by pi over 180. So this will be 315 times by pi over 180. Okay. Now, what's going to go into both 315 and 180? 5 will. So 5 going into 315 is going to be 63 times. 5 going into 180 will be 36 times. Now that's simplified it down. You may have already recognised there's a bigger number that goes into 315 and 180, that's fine. So this is now equal to 63 pi over 36. Now if I look at both the 63 and the 36, 3 will go into both of those. So 3 goes into 63 21 times, and 3 goes into 36 12 times. So this is now equal to 21 pi over 12. Now I know that we now have 3 will go into both these. 3 goes into 21 7 times. I should have used a red for that. So 3 goes into 21 7 times, 3 goes into 12 4 times. So this means that 315 degrees will end up as 7 pi over 4. Now, if you had have identified earlier that a bigger number will go in, 45 will go into both 315 and 180, you could have cancelled down the 45 for both of them, got straight to the 7 pi over 4. But this is just showing you some steps of breaking it down so that you can get there in smaller steps if you're less comfortable with the big numbers. So the answer we have for this one is 7 pi over 4. Okay, next slide. Express the following in degrees. So we have the same relationship that we had before in that pi radians is equal to 180 degrees. So when we're converting 2 degrees, then we multiply by 180 over pi. So that's the key that we need to do here. So the first one here, we've got to be multiplying it by 180 over pi. And we're going to cancel the pi's down. That will give us 180 over 4. What goes into, 4 goes into 180, quarter of 180 is 45. So this one's going to be 45 degrees. Now this second one, 0.7 of pi, what we need to do with this is convert that to a fraction. 0.7 is 7 over 10, so I'll call it 7 pi over 10. And then we do the same thing, we multiply it by 180 over pi. Our pi's will cancel down, and 10 goes into 180 18 times. So we're now going to be left with 7 times 18, which is equal to 126 degrees. So the last one that we have here, 0.7 of pi is equal to 126 degrees. Okay, I hope you find that useful.